Hello and welcome to another video. Today we have a board of a viewer request for assistance with an Asus ROG Extreme 7 motherboard. Dear Daniel, I've been a long-time subscriber to your YouTube channel. I really admire the expertise and dedication you show to repairing high-end motherboards. Well, I do mostly a lower-end, but whatever. I truly appreciate that you agreed to take a look at my Asus ROG Extreme 7 and help me with the repair. I purchased this board about 2 years ago. I've only used it once. When I recently tried to install 11th gen CPU, I needed to update the BIOS. I followed the official update from Asus website. The update ran through 3 stages. The Aura firmware updated successfully, the BIOS update also completed. During the Intel ME firmware update, however, the board shut down and became completely unresponsive. Unfortunately, I attempted the process again on the secondary BIOS, but the result was the same. Since then, the only thing that worked on the board is the Aura lighting. Also tried using the BIOS flashback function on the RIGOL to restore board with an older BIOS, but that did not work. In addition, I tested with a 10th gen and even 9th gen CPU, but the board remained unresponsive. I later sent the board to a local electronics repair shop. They did replacing the BIOS chip, but that did not solve the issue. During the attempt, the battery holder was also damaged, so if possible, I'd kindly ask you to replace it as part of the repair. I also noticed that the jumper used to select between the two BIOS chips is now missing, and I would appreciate if you could restore or replace it as well. For your reference, the swapped BIOS chip for the repair is also attached to this letter. To make shipping easier, I've removed some of the heatsink shields, both to help you access the board and to reduce the package weight. Because this expensive board that I value a lot, I would be grateful if you could help me restore it, and thank you again for your kind support and agreed helping with this repair. It means a lot. Kind regards, Mohammed. And this is where we have the BIOS chip, apparently. And yeah, so all we have to do, in theory, is to flash the BIOS on this. Theoretically, this should be an easy job, but it could be more problematic. The biggest thing on Asus boards is they have a TPU module right here. A TPU module right here at the bottom. This TPU module works like a secondary EC chip, like a secondary SIO. And this SIO has firmware attached to it. So there's a chip right here that is like a BIOS chip. It's an EEPROM that stores firmware that is related to this TPU chip. And the firmware in this needs to be taken from the BIOS itself. So this is a two-part stage where you flash the BIOS and the BIOS flashes this firmware as well from the TPU chip. And if this firmware isn't working, the BIOS also won't initialize. And the Aura is in between there somewhere, being also controlled, the Aura firmware chip. There are also some more there are more EEPROMs. Like this is, as far as I know, most of the time these are like USB controllers, and they have firmware as well attached to them, but they shouldn't prevent boot. This board is so insanely heavy already. Like he removed the heatsink here, probably removed something here, and still this is so heavy. Like this thing, if you see, it has this complete back plate that makes this board really stiff and heavy. And I hope that in the attempt of someone soldering another BIOS chip onto here, it didn't damage anything. So let's see under the microscope first the area where there has been work done. So I can already see there's definitely a single component missing here. This might be a capacitor, because you can see there's a big plane here. So you can see there's a big plane right there, and that often means that this is a power plane. And this is probably then a filter capacitor. The soldering looks okay. Definitely a little bit damaged of the PCB there. Yeah. This person is not too experienced in like micro soldering, but it should be fine. Let's just see that nothing more is damaged. Okay, this thing is charred. Whatever this is has gotten destroyed. What? Okay, this might be bad, because this thing is like completely charred. Okay. This might be a 1.5 volt regulator because it's near the battery. And that would mean that the RTC section isn't running anymore if this is the 3 volt to 1.5 volt regulator. Let's further see. This is the BIOS selection switch. This is just a jumper. And yeah, this area looks fine. Nothing more damaged, nothing more worked on. Let's see. So the rest looks fine. We will definitely have to get this battery holder out of here, because he wanted us to replace them. And that will also make it easier to have to work on this area right here. So let's start with removing the battery holder then. And of course, the battery holder has to be behind part of the heatsink. So this is one pin and the other one goes up to behind here. So time to take the backplate off in order to remove that battery connector. So that is everything removed, or the backplate removed. I will leave the wires on there for now because I don't plan to take them off to not disturb anything, because these can break and I don't want to deal with that. And now what we do is we have these two solder points right there, and I will be trying to use a big tip, but I think these are too far apart for me to use my big tip. Yeah. So these are too far away. So if you have something like that, I usually recommend just using a big soldering tip. But if you cannot do that, what I like to do, I like to use two soldering irons then. And for this you don't need a second good one, just one that can melt solder. And yeah, what we then do is you're going to be heating up both pins at the same time, and you try to push it through. So that is what we're going to be trying to do now. Let me set up a secondary soldering iron here. So I have another soldering iron set up. And let's do this now. Where, first of all, what I like to do is we need to add leaded solder to both points. So we lower the melting temperature of it. And after having done that, I would recommend to go to a higher temperature, like 400 degrees, and using a big tip. And then we're going to try to heat both joints up at the same time. And then we might be able to push these through. And I think I got it. Let's see here. So I had to get my hands a little bit onto that and pull it out a little bit, but then it worked out and now it's removed. So this board is one of the worst case scenarios for one of these, because this board has a really big ground plane and it's really not that easy to take these out. So, and the bigger problem afterwards is to clear out these holes. So what I like to do to clear out these holes, most people would try with a solder wick, but the solder wick won't work because this has too big of a ground plane. So what I do is I use a solder sucker and I preheat these. So I take my hot air, this is set to 475 degrees, and I preheat this up to a very high temperature where I see that the holes get molten just by the hot air. So you're basically reflowing these, and as soon as you have reflown those, you're going to take the soldering iron and then you're going to heat it up and suck the solder out with the solder sucker. So now you can see that most of the solder is molten. I take out my hot air, use my soldering iron, get onto there, and use my solder sucker in order to try to get the hole cleared. And I think I got it. The best thing to test it is tweezers, if the tweezers go through. And the lower one is definitely cleared out, but I think the top one still needs something. Yeah, the top one is almost cleared. It just needs, it just has a little bit solder left on the top side. I will show you that. So let's go under the microscope. You can see the bottom hole is basically perfectly clear. And when going up, the top one is almost clear. There's just a little bit of solder left that we will now have to remove with braid. But it is clear enough that you could put a battery holder through there. But we're going to clean the rest of it up with the soldering iron. And let's see now, we're going to, if we get this cleared out. Yeah, I think this is now cleared out. Let's see. Doing the tweezers test. And I'm able to put the tweezers completely through. So now the area is completely clean and is ready to take another battery holder in. That I will be taking from a donor board. But area looks fine now. Just this one we will have to take a look at what this is. And then probably also this capacitor that is right there. And yeah, the board is a little bit damaged there and there. Because the person probably took a lot of heat in order to remove and put on this BIOS chips. So let's see. I want to know how this board reacts. Because we haven't verified the fault yet. But we need a BIOS jumper first. So let me find. I think I have jumpers in my miscellaneous tray here. I have a jumper right here, but it's a little bit big. I'm going to cut off the top and then we're going to use that. So now we have a jumper for here. So now we are able to put a CPU into here. And let's see how it reacts, how it behaves right now. So we have a Celeron G5925 here that we're going to put in. Let's put some DDR4 into here. Let's connect power. And this board has a power button, has postcodes, so probably has a speaker also on here. So there's nothing for me to attach to here. So we're just going to see how this board will now react. So, wow, this thing takes a lot of power. 500 milliamps. Okay, that is one of the highest power consumptions that I've seen yet for passive power consumption. But I guess it's fine here because this has LEDs at the backside for the audio, as you can see. This has an LED strip here. This has a screen here with an animation. And yeah, and this isn't even everything. It has underglow. And yeah, really cool motherboard. Really like it. Really fun board. So let's press the start button and see how this reacts. Oh, we don't have a reaction to the start button even. Okay. So, I think this is because of that regulator that we saw at the bottom. Pretty sure. So, our RTC voltage is probably not running. 1.5 volts. And that is why we don't have a reaction to the power button. Or it's also because of the BIOS. Let's see then. Under the microscope. This thing is probably a 1.5 volt regulator that takes 3 volts in and then creates a 1.5 volts RTC voltage. And I think it's broken. So let's see. It's input. I don't get any voltage there. Oh, I do. 3.3 volts. Okay. And this here. Yeah, this is the same plane. And there should be probably 1.5 volts as an output right here. And I do not get anything. Does it get hot? No, it doesn't get hot. Do we have low resistance on there, on that output? We seem to have low resistance there. Yeah, we have a single ohm. So this is probably why this burned up. Because this, as far as I know, is a 1.5 volt regulator that has really low amp output. And the big question is now, why did it burn up? And why does it behave like that? We will have to find out. I will have to see if I can get a board view for this so we can have a better look at this. Let me see. I got a board view. Took quite some time and actually cost quite some money. But I got it now. And yeah, we can see. Let's see. What is this? Yeah, this is okay. This is a Schottky diode this just connects 3 VSB to 3 volt SPI. So the SPI is the BIOS chip. So the BIOS chip isn't powered when this thing is broken. And we saw 1 ohm on this side. So let's see. This probably then connects to a 0 ohm somewhere. This is 0 ohm. No. This probably, yeah, this jumper. This is a jumper. And this connects then to this resistor, doesn't matter, a capacitor. Okay, this is the missing capacitor that we have. Another 1k ohm, so it doesn't matter to both of these chips and to an 8.2k ohm. So, and we have a single ohm of resistance right there. So that means the only thing that can be shorted is this or this BIOS chip. So one of these two BIOS chips isn't properly soldered, or it could theoretically also be this capacitor, but it's unlikely. So what probably happened that it shorted this right here because this was soldered wrong. Then it was connected to power. The 3 VSB went into here, went through the diode and burned up the diode because there's a short circuit on this side. So yeah, we will have to lift that short circuit first via removing this BIOS chip. Maybe even this BIOS chip. We will remove this one and then we'll see for the resistance right there. And after having done that, we will then see when the resistance is gone, we can just replace this diode and yeah, and then program also the chip. So let's do that. So the header is also already a little bit scorched, but we will try to protect it with, this is just a bracket from a PCIe shield. And yeah, this will just be as a shield in between there to shield off some of the heat. So let's now get some flux in here. And I hope that he used leaded solder while doing this in order to get the melting point lower from the board, so that it will be easier for us to remove here. I will be needing a lot of temperature, like 475 degrees is definitely needed, because this board has a lot of a really thick ground plane. So this will take quite some time to remove. But we're going to start with removing the lower one first. And when that is done, we will check for the shorted line. Oh yeah, this removed very easily. Wow. He must have used like low melt solder or something like that. Okay. Let's now see then if we still have a short circuit right there. So let's see here. Right there. It appears we do not have a short circuit anymore. Yep, we now have kilo ohms right there. That is good to see. Big question now is, was this chip, is the chip shorted or is it the soldering that was bad? Let me check the pinout of that chip. So let's check if this chip is dead. For that we need pin 8. We flip this chip around. Let's see. This is pin 1. Then it counts to 4. And then this needs to be pin 8. So that one is pin 8. If that is now connected to the bottom, to the middle pin, we have a dead BIOS chip. And we do not. So I think it was just bad soldering here. And not related to an actual dead chip. So what we're going to do, we're going to clean this area up. We're going to be taking off all of the solder that is here. We're going to put my leaded solder onto here. So let's try to remove all of the old solder here. So it's cleaned up now. Let's first see to put that capacitor back on there. I don't think it's necessary, to be honest, but it's better to have one there because it's for filtering and getting like more stable voltage to the SPI chip. So it definitely has its reason to be there, but it probably will work without it. So let's clean this up. So I got a capacitor right here. Let's solder it on and then we will reflow it later. So we're first going to put it on crookedly and we will reflow it later. So that will be in place as soon as we got hot air into there. So I want to solder on this chip again, this BIOS chip. I'm very interested if the BIOS chip works and has good firmware on it, and that all there was bad soldering. So if I just wanted to get this fixed, I would just flash the BIOS chip, put my own software on there and be done with that. But I want to see if the BIOS chip that they bought is actually fine or not. So it will need to sit on somewhere like that. Let's get some more flux onto here. So, and while we are here, let's remove this. This seems to be have soldered as well, because this removed very easily, which is weird. But yeah, the chip is now on. It now looks fine soldered wise. The capacitor is there. It should be protected, everything here. Let's check now for the resistance if it if we still have a short now. Or have a short again, because we checked in between and didn't have one. Yeah, we definitely do not have a short circuit anymore. Can I get a resistance reading anywhere? Yeah, there's kilo ohms, and this one has even higher kilo ohms. Okay, so now I will have to get one of those diodes. I think I have one in my stock even. Yep, these tend to die more often, and I do stock them. Let's see if that is the right footprint, because this might be a little bit smaller. Yeah, the one that I have has a little bit bigger footprint, but this shall be fine. We should be able to get that into there. So, in order to get that easier into there, we're going to clean up the pads. So, pads are cleaned up. Let's place our new diode into here. So all that this one does is it takes two voltages and puts them into here through a diode. I think you could even you could probably just put a wire into there and bridge those, because the inputs are both the same and it's just 3 volts going out there. So yeah, I do not know why they even bothered to do this. So this is now connected on one side, and now the others just have to be soldered in. And yeah, a little bit bigger footprint is even theoretically better, because this can pass more voltage. But yeah, it's the right part, just in a little bit different package. This is the standard SOT23, I think, package it's called. And then the original one is just a little bit smaller. So let's reflow this capacitor for it to look good as well. So we have solder on there. I want to get flux onto there, and then I want to reflow it now with hot air once more, just to be sure that it sits properly, because this plane is really hard to solder to, this power plane. Right there. Now it's reflowed properly. It's definitely in place. So now let's get this out of here. Big question now is, will this board work now on its own already? Let's clean it up first. So this is the area nice and clean now. And let's check once more if the short turned up all of the sudden again, but I don't think so. I think we should be fine here. So checking right there. And we have high resistance. Checking right here that the multimeter actually shows something. Yeah, kilo ohms. And seeing here, even higher kilo ohms. So this probably has like 200 kilo ohms or something like that. 126, that is good. So we have high resistance now again on that line. We have that diode array replaced because it was burned up. And yeah, this is the replacement chip, I think. So I do not know what kind of content is on there, but I'm very curious if they actually put a good BIOS chip on there, because as far as I know, they bought a replacement with a BIOS on there and tried to solder that. And that would have worked if the soldering was proper, I think. And that's what I want to check out now. So let's see now if that was all that we needed. So let's put power to this. And we now have about 600 milliamps. Let's see if we have a reaction to the power button. And we do not have a reaction to the power button. That is very interesting. Let's see if we have those 3 volts at the BIOS chip now then. So input has 3.3 volts, and let's see, its output also has 3.3 volts. The BIOS chips seem to be fine. They are not hot or anything, but there's no reaction to the power button. Let's swap then, and still nothing. So yeah, this is bad that this still doesn't have a reaction to the power button. This is actually a really bad sign for this board, that there might be something else damaged still. But we don't know of the content of these BIOS chips. So what we will do, we will connect a header to this pin header here, and we will see if I can get the BIOS read out via the header. So I'm currently reading out one of the BIOSes. In this case, it's the header on the right connected. And there definitely seems to be content here, and it looks fine, to be honest. So we're going to be saving this. So this is read out, and now I want to get the other BIOS. So we're going to be reading again with the header being on the left side. Yeah, and this side definitely has different content. If you have a look at this, this looks like someone forgot to convert the cap to a bin, because there's content at the right of the beginning of the chip, and that shouldn't be. So we're going to save this one as left side, and I would want to flash this one with the other one, so that both sides have the same BIOS. Erase operation failed. Okay. Yeah, the chip might be dead. So it might be that we can read to the chip, but not write to it. That might mean that that BIOS chip is actually dead. Because we definitely can read its content, but when we try to flash it, we just get an error. So we will have to take out that bottom BIOS chip, and yeah, what will we do? I think we will take it off and see if only with the upper BIOS we can get a boot out of this thing. Just to confirm that the board is somehow working, or somewhat working. Let's remove the lower BIOS chip first then. So sadly we will have to heat this up again, and it seems like that the previous technician didn't only botch the soldering but also killed the chip in the process. And now the big question is, does this board need to see both chips, or is one chip enough? And that remaining chip, that upper chip that wasn't touched, hopefully, if that works and has a good BIOS in it. So we're going to remove it, and then we're going to test with only that one upper chip. And we might want to flash that upper chip to see. But yeah, let's first remove this one. So I'm very interested how this board now behaves with that BIOS chip removed. So let's see. Does it have a reaction to the power button? It did briefly react, I think, but not quite. Let's hit the clear CMOS button on the back. Let's clear the CMOS. We can see by the power consumption that goes down. Let's see. Yeah, it briefly reacts. Okay, let's switch the BIOSes then to the right one. We're going to turn this off, hit clear CMOS again. And now, let's see now with the right one. No. Okay, so there's still something wrong. So the setting for the right jumper seems to be the lower one, and the jumper to the left seems to be the upper one. I will have to look at that in the board view. Jumper corresponds to what? Yeah, we have a brief reaction to the power button, but something is still wrong. Okay, let's jump into the board view then once more. I want to see which BIOS chip is responsible for what, and I probably will flash the BIOS on here. So let's see, we have the BIOS select switch right here. And if we select these two, then we have the upper one. So with the left BIOS we get the upper one, and with the right BIOS we get the lower right one. So we want this BIOS currently because this chip is on there. Let's now see for the content once more, and we will probably flash it to make sure that we have a proper BIOS on there. So let's see once more for this chip what kind of content this chip will have, and let's get a proper BIOS. So this BIOS seems to be the one that we couldn't write to, I think. Let's try this. So because this has the content at the front, let's get the proper BIOS into here. Okay, it has content like that also. Because this, yeah, this is the one that I have extracted. Okay. But we cannot flash to it anymore. So it's actually the upper one that doesn't want to be flashed anymore. That is interesting. So I will have to swap out the BIOS chips probably. Take out this one. We will flash the other one out of circuit and then put it on and see how it then behaves. So let's do that first then. So I can now program the chip that we taken off, that I thought was the broken one, but the other one is the one that we can't erase to. So this now gets a new firmware or on the EEPROM, and we will have to then connect the middle pin, this one, to this, in order to get these two to flash or to select this BIOS chip that we're going to put on here. And I want to see if we can get boot out of that, and then we will take care of this chip that can't be erased anymore. And if none of that works, we will have to take a look at the TPU chip also, because the TPU chip is closely related to the BIOS chip, as I said before, and it has firmware that is related to the BIOS chip itself. So this might work, but this can also be prevented by the TPU chip for it to not work, because the TPU chip doesn't have the proper firmware on it. But we will see. We will first put this now on and go from there, where depending on how it will react. So the BIOS chip is verified. Let's now take it off and put it back onto the board. So the chip is on again, and this is the one that is flashed, and the BIOS jumper is now set to the right one. Let's see. Let's hope now that we get a boot out of it now. And let's press the power button. And same reaction. That is not good. That is really not good that we have that same reaction. So it still shortly reacts to the power button and then shuts off. And let's see. If we swap the BIOS to the upper one, I don't think there should be any reaction now. So that also has a short reaction to the power button, which is very interesting. So what I want to do is I want to flash the TPU firmware just to be sure that that works properly. So let's have a look then under the microscope. So we have two chips. We have this Windbond chip right here, and we have whatever this is, ATMLH934. Like, both of these might be BIOSes, but I'm not too sure. We will have to take a look at the board view, which one is the correct one, because yeah, this is the BIOS flashback, and there's the firmware for it. So this seems to be also a firmware chip, for this one for the BIOS flashback function. And then we have these two, where this one is a Windbond chip and this one is also a firmware chip. Let's see. Yeah, this one goes to the TPU. So we will have to flash this one because you can see the traces going there. I wonder where this windbond chip is going to. Where it's connected. Because, oh, this is also, is this also connecting to there? Oh, this is bad. Because, yeah, this thing is also connecting to there. That is difficult to know which one is the right firmware to flash. But I think it should be this windbond chip here. This should be, what, a 512K chip or something like that? Let's have a look at the board view in order to see this. So let's have a look. This chip right here, O2 SPI, okay. But this thing is definitely connected also to here, just like this one. This EEPROM is also connected. But this only has clock and data to it. Oh, and this is via SMB bus. So I don't think this is the one that we're going to flash. This is the windbond chip that we are going to flash. We're going to be taking out this one because this is the chip that holds the firmware for the TPU. So let's take this one out and flash it. There is theoretically a pin header here that you could connect to, but it isn't soldered in this case in order to flash the TPU firmware. So let's take this chip out and flash it. So we're going to be protecting this chip with the heat shield again. And let's let it solder onto here so it removes easier. This doesn't have to look good. This just has to be let it solder on all of the pins so that we get an easier removal and with less heat. So let it solder everywhere. And I have my adapter board ready in order to flash this chip. Orientation is bottom right first pin. So we know that. Let's now take hot air and get this chip off. So we now have the chip recognized. 2 MB chips, Mbits chips. So it definitely reads it. Oh, it's basically the same group of chips then as the other one. Okay, let's read it out then. So the chip is now read out. And can this really be? Is this empty? I don't trust that. I'm going to reread that. Okay, no. There was just a wrong setting here. The chip has content. We're going to save this content now as the original TPU firmware. And let's now select the TPU firmware that I've extracted from the BIOS, and it looks fine because this is 128 kilobytes while the original is 256, so that should be fine. And it looks like it's exactly the same. Okay, let's check them against each other. Let's do a file compare. We're going to be open up the original TPU firmware, and we're going to be opening up the one that I extracted. And they are different. They look similar, but they are different. Yeah, they have a few points that are similar, and they have a similar structure, but they are different. So let's open up the one that I got from the BIOS chip, from the BIOS extracted, and let's write that buffer to memory. So now it's programmed. Let's put it onto the board now, and let's hope that that solves our problem. So it doesn't look great, but it's on there and probably has the right firmware. Let's hope that we now get a boot out of this. So let's now hope. 500 milliamps, 600 milliamps, let's start. And it still does not want to start. So we do have a reaction to the power button, but something is still not right. I have finally found something out. It appears that this board overdraws my connector. My PSU connector that I use, the adapter that converts 12 volts, seems to be overdrawn by this main board. So I've currently connected up a normal ATX 24 power supply, and I think we are working now. Let me get a display hooked up to here, because this thing does not have in internal output, which is weird because Intel definitely supports that, but it doesn't have any HDMI. So let me show you. We won't see power consumption now anymore because I now use a standard 24-pin power supply instead of the one that I use for debugging. And have a look now. We now have a reaction and we get postcodes. It's restarting and now it's trying to boot. Cannot believe that. First time this happened to me, that actually my adapter won't work with this. And we get actually postcodes right here also. This is very cool. I've seen this. We are on VGA right now. And we should get a post screen, or maybe we have one already. Let's see. Load VGA BIOS. Okay, this might complain because of my old graphics card. Let's get a keyboard connected to here and see if it already reacts to the keyboard. So my keyboard doesn't say that we are initialized yet. So we are on CPU. Oh, it restarted by its own. Oh, okay. Yeah, now we have a boot. I have a recognition on my keyboard. Oh, it's probably updating Aura firmware right now, because we've changed out the BIOS on here. It's probably updating. So we will leave the board right now. We currently have no real indication of what is happening. The postcodes say it's on detecting HDD, so detecting the hard drive, and it turned off by itself. Let's see, it probably finished the programming of the Aura firmware. Now you can see this better if it would focus. Yeah, and there's the post screen. Oh, that's very good to see. Let's get into the BIOS then. There's the BIOS. So we were fine from the very beginning. So the flashing of the TPU also worked, because this is now the firmware that we put on there with the BIOS, and that has worked. And now we have a post screen here. I want to read up on this board a little bit because this board is kind of weird. Let's turn it off. This board has 2 ways of BIOS selection, which I do not know how it works. Let me go under the microscope and show you what I mean. So this board has this BIOS select one that we see here, and it also has a BIOS select switch with these LEDs and this switch right here. So I will have to read up what overrides what and what actually gets used. And we will have to make sure that the both BIOSes do work on here. Let me confirm that both BIOSes are booting. If that works, we won't do any more flashing. If they don't work, we will have to do some flashing again. So right now, we have the BIOS switch selected to the lower one, the lower LED. And that is what worked. And let's now flip it to the upper one and let's see if this also works. Yeah, and the upper one does not work. The upper one currently gets 7F. But I want to see if when you flip the BIOS select one, this one, the pin header one, if this then works. If you have to do them accordingly to each other, maybe. Let's see now. Yeah, okay. So you have to have them accordingly. So both BIOSes probably do work now. Because now we have the upper LED and we have it on the left pin header right here. Let's see for this to flash. This is currently on VGA code B4. Is this is this? Yeah, it is booted already. Yep. So as you can see, can I move in there? My numlock definitely does react. But the picture is frozen. Oh no, it rebooted, that's why, okay. It rebooted by its own. Yeah, this is the problem with not seeing the power consumption. You can't really tell what is happening to the board. But I just want to make sure that both BIOSes do work on this. So that both BIOSes do get a post screen out of this. Because if both BIOSes are working, I'm not going to touch anything. I'm going to leave it as it is, because then it's working and you can have both BIOSes as backup. But the big thing that confused me is the combination between the pin header and that BIOS switch. So yeah, there's the post screen. Now it's updated. Yep, now we have the actual BIOS. Okay, I want to turn this off. So we now booted with the upper BIOS. I have the selector switch in the left position. I'm going to press it. Now we have the LED in the lower one. Let's see if this boots. And this does not boot now. You cannot see it because of the post screen. It now has 0, 0 and it doesn't move. So if we turn this, so we need to turn this off. So turning it off, flipping the switches, pressing start. Okay, this did not want to boot. We probably have to reset the CMOS for that. So CMOS has been reset. And now we are on the lower BIOS with the right setting. Let's see now. And now we get a boot out of it. Okay, so you do have to reset the CMOS or at least power cycle the board when switching these. So both BIOSes are now working. That is great to see. There we go. Now the lower BIOS is selected and works. That is very good. Now I want to go into Windows just to confirm that like the Ethernet and all of that is working, because we have been messing around with a lot of things like with the TPU and the BIOS and everything. I want to confirm that our M.2 is working on each of these slots and that we have USB and Ethernet connections and everything. And I got to be honest, I have never experienced this adapter not working. I've heard of people saying that this adapter was the problem at the end, that they weren't able to get a boot out of it. But this is the very first board in all of my boards that I have that actually happened, where this actually happened. And yeah, so be cautious of that. I don't know what triggers it. There must be something about it drawing a lot of power. Being that this do not want to work. I think it's correlated to the 5 VSB being overdrawn by this board. And I also got to say this one is the cheap 140 watt version, I think. There's also a 300 watt version that might work with this. But yeah, it does not want to work with this one. That's why it's always good to have a 24 pin ATX power supply nearby in order to be able to test that. And yeah, and also the BIOS switches really confused me. I've never seen a configuration like that. I've seen either or, like either the pins or the switch. I've never seen both on a board before. I might want to read up on this, how this works on the manual. And yeah, so the board worked after the first time we flashed the BIOS chip, because then we had a reaction out of the power button. And that was when the board was actually already fixed. Everything that I'd done after that was just the problem of the power adapter. So yeah, the flashing of the BIOS was necessary and changing that diode out was necessary, because that diode was burnt out as we were able to see, because it wasn't passing the 3 VSB anymore, and the one BIOS chip needed new firmware or needed to be soldered properly because it had 0 ohms on there. Then there was also the capacitor, but everything after that, the flashing it again and then also flashing the TPU chip, that all wasn't necessary, but it didn't make it worse because obviously it works now. So let's get into Windows, and I want to check just for some of the USB to work, and if that works, then I also want to check that the 10 gig and the 2.5 gig is working, and yeah, then we're basically done with this board. I'm going to clean up a few places, and yeah, I will be getting a donor battery from somewhere, battery holder, but that's like, you've seen the worst thing with, which is taking it out. That's the hardest thing about it. Soldering a new one is just holding it in place, and soldering 2 pins on, which isn't anything difficult. Yeah, and now I'm in Windows, and I do get a connection to Ethernet on one port. Let's see if the other one also works. So I currently have a problem of the 10 gig networking not working. but all of the USB is working. I will try to figure out if why that 10 gig isn't working while the 2.5 gig is working. So this might be a software related issue. So yeah, let me quickly fix that as well. So I got the 10 gig networking working. It was just a driver issue like I thought. And I also checked the Wi-Fi that is working. I checked the USB connections that are working. And I think I can say this board is working fine now. And yeah, I hope you learned something from this video about like the BIOS chips and so on and so forth. And the realization that this adapter might sometimes be a problem as well. And yeah, with the diode that was burned. And yeah, I hope you learned something, hope you enjoyed it. All of my tools, as always, are linked in the video description. If you want to get one of these current measuring devices that I sell, email me and you can get one of those. I also have a post about them on YouTube, on community. And yeah, I hope I can see you in the next video. Thank you very much and goodbye.